We are at 99%. Still 2 amps, 56 volts. Okay, I cannot charge this battery any higher. One of the cells has gotten into over voltage protection. I think it was like cell number 6 or so. So this is the maximum we can get out of this battery. The state of charge has now reset to 100% because we had this over voltage protection situation. But the balancer is not great. Cell number 3, 6, 9, 12. I'll tell you more about this later. Alright my friends, welcome back to another video here from the Off-Grid Garage in beautiful, look at this, beautiful sunny Australia. Winter weather once again. We are cranking the amps on all panels. And in today's video we want to do the high current discharge test with the Seplos Polo battery, just with the top one. I have not connected the other two yet. And we want to discharge this battery with around 90 amps, so 0.9 C. We want to see how warm it gets, how is the hardware holding up, and what can we see with the infrared camera. I have also reset the Smart Shunt test to 0. Thanks for reminding me. So we are on 100%. Everything is good. Let's get started. So before we start the test, let's have a look with the infrared camera, what we can see. The BMS is obviously a bit warm from charging it up. Battery was on 58%, so I used the power supply to charge it up to 100% now. And this is the back side of the battery pack. You can see the fuse connections there. There's our fuse connection. Breaker and the balance cables, and here is the BMS again, 32 degrees. Okay, nothing to see here. Battery pack is super cool. I'll put on the lid again. This is how the battery is usually operated, and we also put the top cover back on as an additional thermal insulation. Okay, we are start charging now. I've set the Tesla to 10 amps or 2.4 kilowatts. The Xia inverter fan comes on. We are discharging with 46. Okay, we have to, that is not enough. That is not enough. So what I will do additionally, I will turn this one on as well, which comes from the same battery. And we pull an additional 40 something. So this one now feeds into the multi-plus and this charges then the battery. Alright, what does it say? 78 amps. Now we go one higher. 83, 90, 88 amps. I think that's fine because the current will increase over time once the voltage is lowering in the battery. So 16 millivolt deviation we have. We're pulling 90 amps now. 8 millivolt. I've got two inverters connected to the Seplos Polo battery. Oh yeah, we are pulling 90 amps here. Wow. That is insane. Also, let's have a look at the temperature sensors. They are all on 19.7, 19.2, ambient 20.6. So that all looks good. So let's have a look at the Smart Shunt test here. We're pulling 4,500 watts from this battery now. Wow. Close to 90 amps. 7 minutes in the test and 0.3 kilowatt hours pulled already. 7 ampere hours down. Great. 1 hour and 3 minutes it claims. I don't think we can see the 1 hour mark at all, but maybe I'm wrong. Alright, I'll keep monitoring the situation here. If something interesting happens, I shall let you know. Interesting, the temperatures are already rising. 21 degrees, ambient is inside the box, I assume. Alright guys, see you then. Very exciting. It looks good so far. And we are now at 27% state of charge. We have pulled 72 ampere hours so far, 3.6 kilowatt hours in 52 minutes. So the voltage is now down to 50.4 volts. We are discharging with 91, 92 amps. And the temperatures, now you can see we are almost at 33 degrees. The BMS temperature has increased to 75 degrees. Wow. Around 25 millivolt deviation we have in average. All cells are above 3.14 volts as far as I can see. So that all looks good. Battery is going strong. Alright, we have a shutdown, a state of charge protection has kicked in. This usually kicks in at 5% state of charge, and we have just reached this threshold. So I'm not sure, I thought I have turned this off, but I may have turned it on again for other testing. Under soak protect is on. Damn it. Okay, let's turn this off. Okay. And everything turns back on. And we should continue our journey in just a second. Just a small hiccup. The inverter should come on again. Yep, car charging starts again. And the inverter kicks in. I can see the Phoenix is already flashing red because we have a low voltage alarm. And this one will shut down at 44 volts. When this one measures 44 volts, it will shut down. It will just turn off. And I cannot change the setting at the moment because it will restart the inverter then. Okay, we're at 46 volts now. Close to 100 amps now. Battery 120 millivolt deviation, and the cells are at around 2.8 volt in average. We've got state of charge alarm, cell low voltage alarm, and battery low voltage alarm. We have pulled 3.7 kilowatt hours so far. 86.9 ampere hours. Okay, the Phoenix inverter has now shut down. So we are only discharging now with the Tesla. Okay, we are down to 1.6% anyway. So the battery will shut down any moment. We are discharging with 40 amps only for the last couple of minutes. Now the vehicle is not pulling more power now because the voltage is so low. The inverter cannot cope and stabilize the voltage anymore. 212 volt only output of the Xia inverter at this voltage. I mean, we are down to 44 volts. So I think the Xia inverter will shut down any moment here. Okay, 44 volts. 90 ampere hours we have pulled so far. And 3.8 kilowatt hours. We probably reach the 90 ampere hours. But that's it. 42 volts. The inverter will shut down any second. 2.5. Cell number 15 will be our disconnect. Or the inverter shuts down before that. The inverter has shut down, the Xia inverter has shut down. So all the load is gone. We have pulled almost 90 ampere hours out of the 100 ampere hours and 3.9 kilowatt hours of energy. It is quite a bit short actually to the claimed 5.1 kilowatt hours but we drove the battery with almost 1C, so it is actually expected that the battery doesn't deliver the full capacity or energy. Alright, let's measure the temperature. So what do you have here? 28, 24. The side where the BMS is 28. Battery pack 33, 34. BMS is 50. The fuse 31. Circuit breaker 35. And this is what we can see. Let me pull off this cover here. We've got the reflection then. Not a good idea. Alright, so we've got the battery here in the middle, which has a temperature of around 36 degrees. Look at the cabling. This is our main positive going to the terminal there. And here the circuit breaker. That's the circuit breaker connection with 42. The circuit breaker itself. And now we are turning slowly. You can see the balance cables there. And this is our BMS. Obviously the hottest part. That's the heatsink with around 52 degrees there. And the battery itself seems to be fairly equally heating up. Alright guys, so far this video from today, doing the high amp discharge test with the Seplos Polo battery here. There's no problem to pulling this 1C from this battery here for 1 hour until the battery turns off, or your inverter turns off actually. There are no major hotspots inside this battery here, everything is nice and equal warm. Well, and if you are going to pull that much power from one of these batteries here, really consider getting a second one at least, or even a third one, because pulling 1C from the battery is a lot. Alright guys, as always, thank you so much for watching. Thanks for all your great support to all these wonderful and exactly beautiful people out there who are supporting the channel financially as well as buying me a beer from time to time. Thank you very much. And until the next video guys, when we will have a look at the Seplos BMS version 3 with some cool features but also some disappointments. Until then guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.